Hello folks! Well, now that we've gone through and looked at a whole bunch of different data types and some of the common operations on them and issues associated with them, I wanted to take just a little bit of time to go through looking at expressions, order of evaluation, operator precedence, associativity, side effects, that kind of thing. So we'll run through that in this video. You will probably find this one covers a lot of the different pieces of Lab 8 that you're hopefully experimenting with this week. So there's the plan. Let's see what we can see here. So the math operators are pretty straightforward, right? We're all used to the idea of addition and subtraction and multiplication and bracketing and what order we should do things in. So the precedence and associativities rules for most languages pretty closely follow the typical rules for math operations. Where things get interesting is where we start to drift away from that, where we start using different operators that aren't typically defined for standard math operations, or where we start using different data types where there isn't this notion of what order things should be done in. So once we get into those, languages are pretty free to make up whatever they want. And you will find different rules, different sets of operators, different symbols used for those operators, all kinds of different things as you look at different languages. So in this video, we just want to go through and experiment with some of those, look at what some of the options are and what some of the implications are. So you will typically find three common styles of operator in programming languages. The unary operators, where they have just one operand, so something like negative x, where it just takes one value, or x++, that kind of thing. Our usual binary operators, where you've got two operands, so x plus y, or x is assigned y, or x dot y for referencing a field of a struct, that kind of thing. Or the ternary operands, or ternary operators, where they take three operands. If you've been looking at Lab 8, you've seen this one. You might have seen this one previously anyways. This is like the C-style operand where you've got the question mark and the colon, where it takes a Boolean expression and two values as its operands. So we'll talk about that one today. And we'll look at some of the common operators and some of the more unusual ones. So as far as the order of the operands go, this is something that will look pretty different depending on the nature of your language. The most common format we see is to put the operator between the two values, between the two operands. All right, so this is our usual C, Java, Python style, where if you want to add x and y, you say x plus y. Operator goes in the middle. So this is called infix. The idea is kind of the operators in the middle there. The other two styles are to put the operator first or the operator last. If we put it first, it's called prefix. So plus xy to add x and y. And you've seen this in Lisp, right? The idea that you put the function or the operator first, and then all of the things that it's working on. And then the other style is called postfix. We haven't explicitly looked at an example of this yet, but in this case, the operator goes last. So you put the values first, and then the operator last. So x, y plus would be adding x and y. Where you're likely to run into this are more the systems that are geared for stack-based evaluation. If any of you have ever played with some of the old programmable calculators, they did things like this, where you could plop a bunch of values on a stack and plop some operations on, and it would essentially use this stack of data operands as the things to work on, and when it sees an operator, it pops a couple of values off the stack, applies the operation, and pushes the result back on the stack. And the idea is, if you've got a correct expression, then it should work all the way through to the end, and by the time it sees the last operator and applies that last operator, there should just be one value left on the stack, and that's your final result. So just to take a look at one sample expression here. So here's the expression we want to evaluate. 12 is the first data value, 7, 8, and then an addition operator, 3, multiplication operator, and another addition operator. So the idea is we go through left to right. And every time we see a value, we push it on the stack. So we push 12 on the stack, push 7 on the stack, push 8 on the stack. And then when we see an operator, we say, okay, now I'm supposed to do something. So if it's a unary operator, it pops one value off the stack and does whatever with that. If it's a binary operator, it pops 2 values off the stack, does something with them, and whatever result it gets, it pushes back on the stack. So in this case, if we're seeing this as the addition operator, then we're saying, okay, pop 2 things off the stack, add them together, push the result back on the stack. So it pops the 7 and the 8, pushes 15 back on the stack. So now we've got 12 and 15 on the stack. It sees the 3, pushes that on top of the stack, sees the multiplication, and says, okay, I'm supposed to multiply whatever the top 2 things on the stack are. So it grabs the 3 and the 15, pops those off the stack, multiplies them together, pushes the 45 back on the stack. So now we've got 12 and 45 on the stack. And it hits the last addition operation, pops the 12 and the 45, adds them together, pushes 57 back on the stack. So you've got this one value, 57, that's left at the end, and that's your result for the expression. So it is, it's nice, the prefix or the postfix in particular, you can come up with an expression like this, and you never need the bracketing to tell you what order to perform your operations are. Each operator knows exactly how many operands it expects to operate on, and those are whatever the top n values are on the stack. So it does get your order of operations fairly precise, just maybe a little less readable for those of us who are used to working in an infix world. All right. In terms of data types and operations, again, we're all used to the standard math operators, but by now you've seen lots of other kinds of operations. You've seen, string operations and, struct operations and that kind of thing. So usually the idea is we've got one set of operators for each different data type. So you'll have a string addition operation, that's probably concatenation. You'll have, a float addition. You'll have an integer addition. So you'll have all of these different operators that are defined for specific groups of data types. So Boolean operators, integer operators, real number operators, etc., etc., etc. The symbols that we use for those may overlap. It's important to distinguish the operation we're thinking of from the symbol. So the plus sign might represent, again, integer addition or real number addition or string concatenation. So we should make sure that mentally, at least, we're thinking about the difference between the operator and whatever character or set of characters we're using to represent it. And of course, this varies a lot between languages. Right? What you build in as operations that are part of your language and what symbols you use to represent those differs a lot. And of course, the choice between infix, prefix, and postfix. Some of the more interesting parts of dealing with data types and operations is whether you let the user change your operator set somehow. So is the user able to overload it? So can I give new meanings to the plus symbol? Can I create brand new operators? Can I use, question mark times equals to mean something new? So can I create my own operators? And if I'm doing things like this, do I also give the user the ability to define the associativity rules and the operator precedence rules for these new things that we're creating or these things that we're overloading? Most languages won't let you change the associativity or the precedence rules for an existing operator, even if you overload it. So even if you want to give it a new meaning, it's still going to have the same associativity rules, the same precedence rules as the other existing operators that use that particular symbol. So plus will always be lower precedence than, plus symbol will always have a lower precedence than a times symbol, for instance. Some languages do allow you to control this more rigorously, but it complicates the creation of your compiler, because all of a sudden you've got different precedence rules for these particular tokens when they're representing different kinds of symbols. So it's not commonly done, but once in a while you can find a language that does this. So I'm going to look at a few of the different common operator types. Well, obviously, assignment is a pretty common one. The syntax is going to vary from language to language, right? Whether you use the Pascal style colon equals, or the C style just in equals, or whether you use the R style less than dash. There can be all sorts of different symbols that you use depending on the language to carry out assignment, but the idea is we're copying a value into a variable someplace. And they're pretty much universal. I'm trying to think, I can't think of a case where they go from left to right. All the languages I can think of, you take the value on the right-hand side and assign it to the variable on the left-hand side. There is probably an exception. I mean, there's hundreds, if not thousands, of languages out there, so there's probably an exception to that, but I can't think of one off the top of my head. One of the interesting ideas is, can I use an assignment statement within a larger expression? So can I say something like x is assigned y is assigned z? And if I do, what does that mean? So essentially the idea for an expression like this is that this assignment on the right-hand side in this case actually returns a value in addition to taking what's in z and putting it in y. So if you like, this expression y is assigned z evaluates to z. So it puts z in y, evaluates to z, and then that new value is used to assign a value to x. So from a programmer perspective, it just looks like we're going from right to left, saying, okay, assign z to y, and then to x, and then to whatever, and you just go through the chain. But if you're thinking about it at a deeper level, we're saying this really is an expression whose value is this thing on the right-hand side. You also get compound assignments, right? Things like our plus equals, where, again, they have a unique meaning. In this case, x is assigned the value of x plus y. So the old value of x plus y, put that as the new value of x. Or things like our plus plus, effectively being a shorthand for x is assigned the value of x plus 1. In terms of the most common unary operators, again, these are the ones that take one operand. We've all seen these, things like the x plus plus, or the x minus minus, or the plus plus x, or things like not x to complement something, to flip something, or there's the bitwise complement, or a numeric negation, negative x. All of these things take a single value and do something with it. So in this case, we need to know what the associativity of this thing is going to be. Does it go from right to left or left to right? And since there's only one value you're working on, it's usually pretty obvious. Right? If I was to have not x, it would have to do the one on the right-hand side first, and then the second not on the left. So if the value is on the right-hand side, you're going to go from right to left. If the value is on the left-hand side, then you're going to go from left to right. So that's pretty intuitive. One of the things that you might not have played with too much, although you actually may have seen it in some of the for loops and things, is the comma operator. So this is, typically you'll see it in C and C++. And this one's a little different. The idea is you have two expressions, one on the left, one on the right, with a comma in between them. And the idea is you evaluate the expression on the left first, and then the expression on the right, and then return the result of the right-hand side expression, the one that you did last. So if I was to say something like this, x is assigned plus plus y, comma, y times x, then I'm saying, do this thing on the left side first. So the first thing we'll do is the plus plus y, add 1 to y. And then once we're done with that, do the thing on the right. So multiply the current value of y, so this is the new value with 1 added to it, by z, and return that as the result of this comma expression. So this would add 1 to y, multiply that by z, and put that value in x. Now, if you've had a look at Lab 8, you'll see in, I think it's Lab 8A, you're dealing with an expression that's got these commas in it. So you do have to play with this a little bit. Let's see, the other one that I wanted to mention in particular is the ternary operator. So this is also a C++ idea. And for this one, we're interested in essentially embedding an if-then-else into an expression. So it's like having an if-else statement that returns a value. And so the syntax is you have your condition first, and then a question mark, and it's saying, is that condition true or false? And then you'll have a value, and this is the value to return if the condition was true. And then a colon, and then the value to return if false. So if I was to say something like y less than z question mark y colon z, I'm saying, is y less than z? If so, return y, else return z. Or I guess the expression is not so much a return, the expression evaluates to that value. So does this expression evaluate to y, or does it evaluate to z? In this particular case, we're saying, well, if y is smaller, it evaluates to y, otherwise it evaluates to z. So this is effectively assigning the smaller of y and z to x. Now again, if you've been taking a look at Lab 8C, I think it's Lab 8C, you'll see that you do have one of these ternary operators that you have to do some experimentation with. When we start dealing with complex expressions, one of the really twisted things to try and figure out is what order the operations take place in, but even more so, what order side effects take place in. So if we've got things like the plus plus and the minus minus, and if we're making function calls that return a value but also have side effects, then we really need to know what order things are happening in to figure out what this evaluates to. And I guess from a practical perspective, we're probably better off not putting in weird complex expressions that have all sorts of side effects, because they are tough to figure out, right? It's tough to figure out what the right sequence of events is going to be, and it's going to be even nastier for whatever poor soul has to come along and maintain your code. So it's not something that you want to do, but unfortunately it's something you're probably going to encounter in other people's code. So how that's handled varies a lot from language to language, and this is one of the things that you're playing with a lot in Lab 8, is to try and figure out what order these things are happening in. So just to pop over to the Lab 8 slides that we had earlier, right, one of the expressions that you were given to deal with is this x is, or z is assigned x plus, and then we've got this comma expression, x plus plus comma y. So as we saw a few minutes ago, in theory, this is going through and doing the x plus plus, and once that's complete, doing the y minus minus, and then returning the y minus minus, and then lumping that into the middle of this x plus, our expression result times y. Or we were looking at the function call. So we've got a function that has some side effects, and it's being passed x plus 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 x, and the address of x, and another plus plus x, and we want to go through and figure out, okay, what order are things happening in? Presumably, it's got to evaluate those parameters before it makes the function call. So in theory, what we really need to know is which of these things happen before the function call and which ones happen after. So which of the x plus pluses and plus plus x's happen before and after the function call. But we also have to worry about, well, I've got these 3 increment operations taking place here. I've got an x plus plus, and I've got 2 plus plus x's. If I'm going through the parameter list from left to right to evaluate things to pass to the function, then those x's are going to have different values than if I go through and evaluate them from right to left, let's say. So again, part of your goal for Lab 8 is to go through and figure out, and just by observation and experimentation, what order C is actually doing these things in. And then, of course, the other thing we were doing in Lab 8 was playing with that ternary operator. where you've got a function that's got a side effect and it's returning a value, and you're using that in a ternary operator. And if the value is true, then a pre-decrement on z, and if the value is false, then another call to this function with a side effect. So again, the idea is for you to go through and experimentally validate what order all of this stuff is happening in. All right, so order of side effects, something you'll have a bit of a chance to play with. The last thing that I wanted to mention along these lines is the idea of short-circuiting in expressions. So sometimes you don't need to evaluate the entire expression to know what the answer is going to be, what the result of the expression is going to be. So, for instance, if I've got an expression like x times y times z, and x is 0, I know that the x times y is going to be 0, and I know that the x times z is going to be 0. Right? I know that as soon as I see a 0 in any one of these x, y, or z, I know the result's going to be 0. I don't have to carry out the rest of the evaluation. Or if I see an expression like x or y or z, right? If x is true, I don't care what the value of y is. I don't care what the value of the other side of that expression is. If x is true, I know that this whole thing is going to be true. So as soon as I see a situation where I can look at one value or one part of an expression and know right then and there what the answer to the whole thing is going to be, theoretically, I could go through and just stop the computation there, return the result of the expression, and not even look at the other parts of the expression. So this is the idea of short-circuiting, and it's associated with particular operators. So in this case, this would be more a line where if I had a ternary multiplication operator, if I saw one value that was 0, I could quit. If I've got a binary multiplication operator, if I've got a 0 on one of them, I don't need to look at the other operator. Or for the Boolean operations, if I've got a binary OR operation, if I see one of them's true, I don't have to look at the other operand. So short-circuiting, as soon as you know the answer, don't bother evaluating the rest of the operands. In languages that don't short-circuit, then it doesn't matter, even if I already know that x is true, if I already know that x is true, and so this thing is going to evaluate to true, I'm going to go on and evaluate y anyways. I don't bother short-circuiting. It makes for simpler programming from putting the compiler together. Right? You don't worry about whether you're supposed to short-circuit or not. You just always evaluate the whole thing. But where it's really got an impact is the situation where our operations have side effects. So again, suppose this multiplication expression was x plus plus times y plus plus times z plus plus. If I knew that x was going to be 0, and I knew that the result of that first multiplication was therefore going to be 0, and I didn't need to evaluate the y, then if I'm short-circuiting, maybe I don't perform the y plus plus because I don't look at it. Whereas if I'm not doing short-circuiting, if I'm doing a full evaluation, then no matter what, I go through and apply all of the side effects. So whether your language does or does not use short-circuiting is important to you if you run across situations where you've got expressions with side effects embedded in them. We need to know, yes or no, are those side effects going to be applied no matter what? So that's the important one to keep in the back of your mind there. And again, you can go through and create experiments on your own to see if C or C++ short circuits, or if Lisp short circuits, or if whatever your other favorite language is short circuits. So I would highly recommend you do some experimentation with this kind of thing. See what some of the implications are. Again, if you've got a complex expression in your code and it's got side effects in it that don't seem to be taking place, then maybe this is the reason why. So just things to keep in mind. All right, that pretty much wraps up our handling of expressions. Next, we'll get into blocks and if statements and whatnot.